total internal reflection. Total internal reflection. When light travels from an optically dense medium to a rarer medium, it partly reflected back into the same medium and partly refracted to the second medium. If the angle of incidence is gradually increased, one will notice that at a certain point, the refracted ray deviates so far away from the normal that it reflects rather than refracts. This happens when angle of incidence in the denser medium is greater than critical angle for the given pair of media. This is called total internal reflection because the whole of the light is reflected back into the denser medium. Critical angle for two given medium is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree. For the ray AO3 in the figure, the angle of refraction is pi by 2. The refracted ray is bent so much away from the normal that it grazes the surface at the interface between the two media. The angle of incidence, angle AO3N, is called the critical angle IC for the given pair of media. Applying Snell's law, sin I by sin R is equal to N21. Applying Snell's law, the refractive index of the rarer medium with respect to the denser medium is given by 2N1 is equal to sin IC upon sin 90 degree is equal to sin C, because sin 90 degree is equal to 1. The refractive index of denser medium 2 with respect to rarer medium 1 will be 1n2 is equal to 1 upon sin IC. Total internal reflection in nature and its technological applications. Mirage. It is an optical illusion occurring in deserts and on coal-tarred roads on hot summer days. An object, such as a tree, appears inverted to distant observer who gets the wrong impression of a pool of water in which tree is reflected. This illusion is called mirage, which occurs due to total internal reflection. Phenomenon called mirage is especially common in hot deserts. Light from a tall object, such as a tree, passes through a medium whose refractive index decreases towards the ground. A ray of light from such an object successively bends away from the normal and undergoes total internal reflection. While moving in a bus or a car during a hot summer day, a distant patch of road, especially on a highway, appears to be wet. Diamond. Brilliance of diamonds is mainly due to the total internal reflection of light inside them. The critical angle for diamond-air interface, 24.4 degree, is very small. Therefore, once light enters a diamond, it is very likely to undergo total internal reflection inside it. Prism. Prisms designed to bend light by 90 degree or by 180 degree make use of total internal reflection. The critical angle IC for the material of the prism must be less than 45 degree. Prisms made of crown glass or dense flint glass is used for this purpose. Optical fibers. Optical fibers are extensively used for transmitting audio and video signals through long distances. Optical fibers typically include a transparent core surrounded by a transparent cladding material with a lower index of refraction. Light is kept in the core by the phenomenon of total internal reflection, which causes the fiber to act as a waveguide. You might have seen a decorative lamp with fine plastic fibers with their free ends forming a fountain-like structure. The other end of the fibers is fixed over an electric lamp. When the lamp is switched on, the light travels from the bottom of each fiber and appears at the tip of its free end as a dot of light